currently live. I apologize, I'm currently running late today. Alright, I'm gonna do an audio check real quick. Okay, booting up the game. Okay. And we're gonna do an audio check pretty soon. Just gonna get the game loaded up here. Alright, testing 1, 2, 3. Testing 1, 2, 3. Okay, I think that's okay. I want to do one more audio check before we continue. Okay, I'm doing another audio check here. Okay, that's good. Music is not too loud. Yeah, there was a time where there was a previous stream that I had done where, yeah, sorry, I said that there was a stream that I did a while back, and what happened was the oh, sorry, I just lost my train of thought. I apologize. Okay. So I think we are good to go now. So yeah, what was I talking about? I forgot. Oh, okay, yeah. So there was a previous stream where the music was louder than my voice, and when I listened back to the recording of it, it was too much, and I decided to make sure that doesn't happen again. Whoa, what is going on here? Yeah, so this is this is a beast of a tower, Phil. This is the uh, yeah, this is a nuclear power plant that I built in the game. Yeah, this is a bit weird because the last save I did, this thing was running just fine. Now it's not running at all. I'm not sure what happened. Yeah, I'm checking the fuel line to see if problem with the fuel. Yeah, um, this tower goes up um, 1.5 kilometers, which is pretty insane. Nope, I did not hold back on scale. All right, so it looks like um, yeah, I don't know what happened. It looks like the save files didn't transfer correctly to my account. I'm gonna go back and see what's going on with that. Yeah, I'm just pulling up the save file folder to see what was the history of my saves. What went wrong? Yeah, sorry. I switched to full VTuber mode while I look at the save files. Yeah, I'm looking at the save files. They seem to be fine to me. I don't see any problems there. So yeah, it looks like the blueprints also transferred. Yeah, I'm not sure what is going on. Why this is happening. Very odd to me. Hey Tam, thanks for joining the chat today. I apologize for being all of a sudden with my announcement of the stream today. I totally forgot to announce it at a much earlier time. Whoa, wait a minute. What is that? What's wrong with the package there is? Oh, sorry, let me switch to game mode again. Yeah, so I looked at the save files, and it looks like I did transfer the save files correctly to the most recent save files, but yeah, this is not running the way that it was running earlier today on my other account, and yeah, I don't know what happened. It looks like the game just failed to save things correctly, because like these packages are empty right now. That literally didn't happen before, and there's no fuel rods coming down the stack as far as I can tell, which is also something I've never seen before. So I'm gonna go look upstairs and see what's going on with the fuel rods. Okay, the electromagnetic control rods aren't running. Okay, so I think, okay, so that means yeah, limiters aren't running. That probably means that the plastic isn't running either. What? I've never seen this before. Like, this clearly looks like a bug. Like, if you look at this fuel generator, or alternate diluted fuel generator here, or sorry, blender, it has water and fuel in it, but it's not producing any fuel. Okay, so I guess that was a visual bug. So it's not producing any water. Let's see. Okay, so it's jammed on empty canisters. Okay, that's interesting. All right, so let's go outside and Yeah, this is so weird because it was literally running fine. I didn't see any issues. Okay, so this makes sense. So the empty canisters is jammed from what I can see. Alright, so I'm going to put in the storage buffers on these packager arrays again. Yeah, I'm just replacing this loop of belt here with an empty canister storage, so I can loosen up some of these buildup of empty canisters on the line. So yeah, I'm getting the feeling that I'm gonna have to address this empty canister jamming that I keep seeing happening in these different weird scenarios that I keep encountering in the game. I honestly don't understand how this happened because I was literally running this save file on my other account and it was literally like the plane was at full power. I didn't see any issues. I save the game, transfer it over here, and then it literally breaks it. And that is so weird to me. But yeah, I think what I'm gonna have to do after seeing this happen a few times already is I'm gonna have to build a system that can do a better job at at handling these types of weird problems. Because the whole point of this factory is to be as simple as possible from the end user's perspective, and I don't want to ship this these blueprints off as a final product until when it's having this types of problems. This feels too much of a hassle, I think, from other users' perspective. So I recently went to Satisfactory Reddit community and I posted my blueprints and screenshots asking for volunteers to provide feedback on the design to make it more intuitive. So we'll see if I get any feedback next week. If I don't, I still have some things to document the next time around. Oh, whoops, sorry, this is the wrong line. Alright, so we're going to No, I'm not really feeling good about this packager setup, to be honest. I'm trying to figure out how I'm gonna change these packagers to make them less of a hassle from the user's perspective. Okay, so we put storage buffers on on the ends of these packagers to help free up the empty canister line, and we can see that things are now freeing up on the supporting factory side going up the stack, because these two water lines going up go all the way up to feed the factory at the top. And for some reason, I honestly think this has to, I honestly think this has to be a bug. Yeah, so something that I was thinking about doing was reworking the packager blue or the water extractor rigging blueprint so that it's set up with a shared feedback loop. The purpose of this feedback loop would prevent jamming, because what's happening is, because of how the manifolds are connected on the stack, what's happening is empty canisters are migrating across the lines, and they basically go all the way over here and jam up the lines. And the the only fix I can see right now, if I decide to not fix the nuclear power plant blueprints, then the only other solution would be to put some type of feedback loop on the water extractors. Yeah, I'm gonna be well, sort of. There's another route that I should also take as well, which is I need to actually sit down and do a pen and paper calculation. Yeah, so the backup plan is to do a pen and paper calculation to verify mathematically what this manifold inside is doing. So this is what the water manifold looks like on the inside. You can see it has this horizontal linear array of mergers and splitters that load and offload all of these different package fluids and empty package fluids on the lines. And it's not clear to me how what is the actual behavior of this system, and the scale of it is pretty large, and I think that needs to be addressed, because as long as I don't fully understand how it works, I'm always guessing as to how I'm supposed to handle it on the packager side. Alright, so I'm going to take a look at the oil blueprint over here, see if that water is flowing. Okay, so now we have fuel being made, finally. That's good. You think these... Wait, what did you say? Oh yeah, you're right. Yeah. So Phil just said that those packager lines, water package lines, look like a waterfall, and like yeah, that is sort of aesthetically what I was leaning towards a little bit when I was designing this system. Okay, so we're still waiting for, looks like AI limiters. Not sure where I forget where the AI limiters are. Okay, so we have some electromagnetic control rods being made. So that's good. Now, for those who are wondering about these blueprints or using these blueprints on their save files, you do not have to build everything vertically. You do not have to build the reactors and the particle accelerators in the stack. You can actually just take those out and lay them out horizontally and build your own manifolds that way, and you can build your own water piping system as well. The reason why I was doing this was because I just thought it looked really cool to build the reactors vertically, because you have this really nice blue vertical accent that goes all the way up the stack, but that's totally unnecessary. You can totally run this tower without putting the reactors in at the bottom of the tower. That's actually why I designed it that way. One of the reasons why I put the nuclear reactors on the bottom of the stack was to give the user the option to literally not put them on the stack. They can literally just lay them out horizontally, and that's fine. But if you want this tower to look really amazing aesthetically, in my opinion, then you would want to put the reactors in the stack to get that really cool blue light accent on the corner of the tower. But yeah, there is clearly a problem with the packagers, and it's not clear yet how I'm supposed to fix that. So right now, I'm just moving all these different packagers um, to this other side over here. Oh no, no, Phil, this is not. This is just empty canisters and packaged water. It's not packaged fuel. Yeah, so what I'm currently doing is I'm literally just moving all of these empty canisters around to help get the flow happening faster. Oh, you know what? I just realized something. We don't have a we don't have a 600 limiter on the back end of these storage buffers. That might make a difference. Alright, so I'm gonna... Yeah, so I'm gonna build a 600 limiter here to prevent water from backing up on the... or piling up in the storage bins. Yeah. Pretty slick. Yeah, I'm trying to build this vertically here. Oops, that's not what I wanted to do. Okay, no, I'm not trying to double anything. I'm just trying to build a 600 limiter in this buffer storage container. Yeah, because what's happening is water, when it's going inside the buffer, it's going at 780 per minute. And that is too fast. So, or sorry, there's like an excess of 180 going in the storage container. And because there's nothing limiting that 180, it's going to start pulling other empty canisters from the line from other other stuff. So that's why I'm trying to fix this. Sorry, let me fix that. I think that's what I wanted to do. Okay, so yeah, this will prevent stuff from getting into the line or the buffer too quickly. Alright, so we will set this up now. Alright, here we go. Get rid of some of this quick wire here because we don't need it. Yep. Okay, so the reason why the 600 limiter on the behind the buffer is important is because it prevents 100 an additional 180 empty canisters per minute going inside these buffers, which means that if there's anything that is flowing an additional 180 per minute in these water manifolds here, let me go inside so we can see what I mean here. So anything that is flowing through these return empty lines for these empty canisters, they will, because everything coming down these lines is forced at 600, it can't go any faster than that. It has to go then start migrating across these lines to start populating these other lines. That's the reason why you have to have that. If you don't have that, then it'll just continue going straight down at 780, and then it'll start stealing empty canisters from other adjacent lines. Okay, that's why that's bad. So that's why I'm fixing this. Yep, so now I just gotta, I gotta replace all of these lines, or these storage containers with this special one that I made here. Oh, there it is. Sorry, I was making an adjustment there because it wasn't lined up with the other ones. Yep, so you can see we have a Mark IV, which is 480 per minute, and we have a Mark II, which is 120 per minute. 120 plus 480 is equal to 600. So that's a 600 limiter. Yeah, so I wasn't entirely sure what we were going to be talking about today, but I'm getting the vibe now that I think, or sorry, what I should be working on today, and now I'm starting to get this vibe that like, yeah, maybe I should be working on fixing this empty canister problem that keeps coming back to haunt me. These storage containers feel alright. But yeah, I think what I'm gonna have to do is integrate these into the water rigging blueprints. Yeah, it does kind of look like a circuit board with all these different belts going back and forth. What belt spaghetti? I didn't build any belt spaghetti. What are you talking about? Yeah, so the plan for getting these empty canisters to flow smoothly is to literally just move these different empty canisters across these different storage buffers, because because again, the way that the horizontal manifold in the stack is set up is that it's because all the lines are shared in the same manifold. What's happening is empty canisters are migrating across different lines, and by moving these different empty canisters around, I'm fixing that problem. But yeah, my concern with this setup is this might be too much finicking that the user is going to have to do when they set this up. Yeah, so what I can do at minimum is I can um, build or integrate these limited storage containers into these water extracting blueprints. That's one thing I can do. The other thing I can do is the other thing I can do is I can put a return line that acts as a feedback loop on the back end of these packagers, and all that it would do is it would just take excess empty canisters from the bottom and move them back up to the top, and but that's gonna take a while for me to build that. I'm sorry, Phil. What was your question? Oh, you're asking me how am I going to integrate the return line, or what my plan is for that? Yeah, so I think it's just going to sit on top, and it's just going to go horizontally across all these packagers. Hopefully that's actually limiting it. I think it's limiting it. I think so. Yeah, I think so. I think it's limiting it. Yeah, so the return line essentially would do what I'm doing right now, which is moving all of these empty canisters out from here, from the bottom up to the top. That's essentially what it would be doing. I just haven't figured out how to neatly integrate it into the packaged or water extractor rigging blueprints yet. Excuse me. Yeah, I'm kind of surprised because it feels like it's not actually achieving equilibrium right now. No, the pipes, the pipes on the bottom are fine. It's just the empty canisters are not fine right now. I need to figure out how to fix this. Something doesn't. Oh, wait a minute. Hold on a second. I think I might be thinking about this the wrong way. These lines aren't moving very fast, and that could be partly causing some problems here. Okay, yeah, something is not adding up here. Okay, I need to check. I'm gonna go check the water on the factory side because it looks the factory may not be getting hydrated properly. So let me take a look at that. Alright, so check the oil. Okay, that's interesting. So I don't see any empty canister problems here on this end. That seems fine to me. I don't see any problems there. Yeah, so I'm actually a bit concerned right now in terms of like building a return line as a feedback loop, because the the reason why I'm concerned about that is because it's not clear to me if one line of 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 a Mark II would be sufficient, because it could be that it could be mathematically that there's more than a 780. So actually, let me do some quick math here to see. So one way of thinking about this is each line has an excess of 180 per minute. So if we have 16 lines and each line has an excess of 180, then that would mean that you would have an excess flow of 2,880. So, and if we divide that by 780, then oh wow. Okay, so that means that the throughput of the backup that would have to be rerouted would have to take up 4 Mark IV belts, which is sorry, 4 Mark V belts. So that's pretty insane. I never had thought of that before until now. And I'm still blown away by the fact that I did not see this happen until I did a save transfer. That is really bizarre to me. Now, actually, how can we be, actually, hold on a second. How can we be having excess if I put a limiter on the back end over here? That doesn't make any sense. I think I'm missing something. Yeah, so this is weird to me, because like it shouldn't be migrating if we've limited the lines to force them to be 600. The backup has to force the system to literally go to different lines. Okay, so the empty canisters are coming in from this side. And they go here, and then the empty canisters, where do they go? Canisters go over here. Okay, so that makes sense. So yeah, the empty canisters do migrate to from one end to the other. That's inherent to this design, and that's almost unavoidable. But there's supposed to be a limit to how much migration is possible between lines, because again, we are limiting the lines by 600 a minute. So they will they have to back up, and when they back up, they have to start migrating this way across the stack. So yeah, this is where I'm kind of confused. Yeah, the aura does look pretty beautiful. Yeah, I just fixed the tracking a little bit. Oh no, okay, yeah, I don't know why it keeps losing tracking of my face. Not sure how to fix that. Hmm. Or wonder if I should move the camera down a little bit. Fixes the problem or not. So yeah, I don't, yeah, so mathematically, I don't see the point in creating a return feedback line, because because the lines should by definition back up, and when they back up, that should force the system to move correctly. Yeah, they should naturally back up over time, and I shouldn't have to build some convoluted return feedback loop. So it's not clear to me if that's going to be if this is going to be addressed or not. Hmm. Okay, so it looks like the empty canisters are slowly approaching equilibrium, because I haven't added I have not added any new canisters to the system. I literally, all I've been doing is just been moving them around, and I put in a limiter to make sure that they can't, uh, I forgot what I was about to say. Alright, so I'm gonna let the system kind of achieve equilibrium, or kind of let it, yeah, achieve equilibrium. So in the meantime, I wanted to show something that is something that I was working on the past few days. So I actually have finally built something that I've actually never built before, and that is I've built a harmonic load balancer. Can you guess, Phil, what a harmonic load balancer is in Satisfactory? You're still a bit far off. So what a harmonic load balancer is it does a perfect load balance of different factory buildings that are set up in a linear manifold. So all of these reactors in this vertical stack are connected in a linear manifold, and that is a bad thing, because each reactor can hold up to 50 uranium rods in their internal storage, and because they're in a linear manifold, then the reactors at the bottom of the stack are going to need to be filled up. The buffers need to be filled up to, yeah, they're gonna hog up all the rods first at the top of the stack before they make it down to the bottom of the stack. And the amount of time that it takes for the entire plant to turn on, in terms of like filling up all these different buffers with fuel rods, is a very long time. And to give you a sense of scale, since each reactor is filling up at a rate of 0.5 per minute, then that means that just to fill up the last buffer in the array before we finalize getting to the final reactor, you have to take 50 and divide it by 0.5 rods per minute, which gives you a total time of 100 minutes just to go from this reactor to this reactor. So it takes almost 2 hours just to go from 14 to 15 down the stack. And it's even longer than that because you have to fill up all these other ones preceding. So it takes several hours. So it takes several hours before all of the reactors are fully operational. And that to me is, nobody wants to wait several hours for that. So what is the solution? Well, the solution is to build these built-in load balancers that limit how much rods the reactors at the top of the stack receive, so the bottom reactors can receive more. Yep, and yeah, so the harmonic load balancers are different load balancers that are placed in the reactors or slot into the reactor blueprints to do that. And I've actually set them up here as on display on the in this demo that I've put over here. So I don't know if you can see that, Phil, but I actually, yeah, so because you can't see the harmonic load balancers because they're in the blueprints, because they're deeply embedded in the blueprints. So I laid them out here horizontally to demo what they look like and how they work. And because I could actually demonstrate that for you right now. So what I'm doing right now is I'm picking up all these different quick wire that were on these belts, because I'm going to use that as part of the demonstration. So each of these harmonic load balancer blueprints have a designated number as 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Okay, so there's a total of 14 harmonic load balancers. Each harmonic load balancer has 3 ports. One is the input port, where the rods are going to be coming in. Actually, let me demo this with actual rods instead of using quick wire. That might look more interesting. Okay. Okay, so I'm gonna place these here. We're not listening to that noise right now. So anyway, yeah, so what we're gonna do is we're gonna put the 75 rods in this storage container, and then they'll go into this input port of harmonic load balancer 15. And what it does is it takes 1 out of 15 of these and Bill, you gotta let me talk, okay? So the 1 out of 15 of the rods will go onto this line, and then 14 out of 15 of them will go down this stack here. And then this is a harmonic balancer 14, which means that 1 out of 14 of them will go onto this line to feed the reactor, and then 13 out of 14 will then go down this line, and the pattern repeats. So if I have 75 of these rods in my pocket and I put them in the storage container, and I have 14 of these harmonic balancers going down with 2 additional lines or 1 additional line. Phil, I'm talking. Please be quiet. So by the time we get to harmonic balancer 2, it will actually let me go down here. So by the time you get to harmonic 2, it's going to split into 2 lines. One goes into the reactor that harmonic balancer. Phil, I'm talking. Please be quiet. Phil, be quiet. So the so this splits. So this one goes into its reactor that it's adjacent to, and then this one goes down to the final reactor. So you don't have a harmonic balancer 1 because it's redundant. Okay, so there's a total of 15 lines that are feeding into the reactors, even though there's only 14 harmonic load balancers, which means each of these lines here these are just hypothetical lines that are just dangling in the breeze. Each one of these should have 1 out of 15 of the entire storage bin's worth of rods that I start with. Okay, and we will actually demo that. So if I put 75 into the storage bin, then each of these dangling lines should have 75 divided by 15 of them, which is 5. Okay, so each one of these should have 5, and we will actually simulate that in this setup right here. Okay, so we got 5 right here. We have 5 again, and we're still waiting. Yep, we got 5 here. We got 5 here. We got another 5 here. We got 5 here. We got 5 here. Another 5 there. So as you can see, it appears to be working. Now, each one of these, for obvious reasons, each one of these harmonic load balancers has to be different from each other because they're working with different balancing ratios. Okay, but yes, as you can see, we have 5, and then we have 5 and 5. So they all did their job. They all perfectly load balanced all of these buildings in a linear manifold. Okay, so that's literally what it looks like. Okay, but again, I moved them outside of the reactors because so that you can actually see what it looks like. So these harmonic load balancers are optional. You do not need them for the reactor to turn on. It's just that if you want the reactor to turn on in minutes instead of hours, okay, that's the critical difference here, then yes, then you would want to use these harmonic load balancers. And because they're optional, they are a different set of blueprints that I've provided, or I will provide, and you can just slot them in. Okay, and I can demo that right now so you can see what that looks like. So I'm going to remove this harmonic balancer 2 blueprint here. I made these little nubs here, these braided nubs on the blueprint so you can quickly identify where it is. So there's another nub right here that you can access. This is just for alignment purposes to make it easier to help align the blueprint correctly. So what I'm going to do is I'm going to remove the harmonic load balancer here, and I'm going to remove these connections here. Alright, so this is what the factory reactor will look like. Okay, if you have it set up normally. So you just have this one line right here that connects this all this does is extracts the uranium rod off of the dedicated external line here. That's all that's doing, and then it's feeding it into the reactor. So what we're going to do is we're going to we're gonna slot in the harmonic load balancer number 2. So I'm gonna go out, I'm gonna find that my blueprint set here. So this is now unfortunately you get a bunch of lag here, and I haven't figured out what it exactly is causing that. I think it's because there's too many nested blueprints. I think that's what's happening here. So I'm gonna move my mouse so that I'm above the reactor blueprint that I'm going to be connecting to a little bit, and then I'm going to use the scroll wheel to rotate the blueprint until so I just pressed H here so that I could do some more checking here. So this nub is correctly where it's supposed to be. Well, oh sorry, that's not true. It's not correct in the it's not correct in the z coordinate position. We have to nudge it up a bit, but it's in the correct XYZ position. This one is also, so this nub is aligned with the power cable here, and then once you, after pressing H, you just press page up to move it up there, and then this nub has to go squarely in between the floor cover here, and then once that alignment is achieved, you'll see that the load balancer has now been placed on top of the reactor, and then you just press left click to lock it in, and now the harmonic load balancer is now installed in the blueprint, and then I'm going to hook it up. So I'm going to remove this belt here, and I'm going to connect this return line here. I'm going to connect this line here, and then I'm going to connect this line here, and now the harmonic load balancer is now connected. And you have to do this for all the remaining reactors on top. So the small numbers, the small dedicated numbers start at the bottom, skipping the first reactor, and then the harmonic balancer number designators, the large harmonic balancer numbers have to go on the top of the stack. And now have done a perfect load balance, okay, of the entire stack. And we can see that it's perfectly balanced, because if you take a look at all of these reactors, you'll notice that everything is turned on, and none of these have any backup of rods in their buffers, okay, which means that the harmonic balancer is doing it, the harmonic load balancer array is doing its job to perfectly balance all these different rods into all of these reactors. So that's the miracle of the harmonic load balancer. Okay, now I do apologize in advance that that there are 15 or 14 of them that you have to install by hand, but I did the best I could to make it as painless as possible. Something else to keep in mind is some of these load balancer blueprints will have Phil, I need you to stop talking for a second. Phil, I need you to stop talking. Okay. So Phil, I need you to stop talking. So some of the load balancers are going to clip into some things here. Okay, this is a bad example. There's no clipping here whatsoever. So let me try to find another one here that demonstrates this better. Okay, so you can see we have a little bit of clipping here, and we have a little bit of clipping there. And I think in some of these two belts clip into each other a little bit. So yeah, that's gonna happen. But like honestly, you're not gonna see that from the outside. You're only gonna see that. I might fix that later, but I'm not gonna do it right now because it's relatively minor clipping, and this clipping is totally fine. Sorry, what I mean is, in a later revision, I'm going to fix the clipping that is happening between these two belts here on some of them, but I'm not gonna worry about this clipping right here because you can't actually see any clipping between moving parts and this concrete slab here. So it looks like it's fully integrated into this thing without clipping a moving part. So I think that's totally fine. But again, this is optional. You don't actually need these harmonic balancers for the system to fully turn on. It's just that all it does is it just reduces the time from several hours to several minutes in terms of turning on the facility at full capacity. And again, I've provided this demo here so you can actually see it in action and working properly, which is nice. Okay, so let's take a look at these empty canisters again. We'll see how they're going. Wow, that is quite the backup of empty canisters. Alright. Oh, I just realized something here. I can actually do a little hack here. Um, I think what I could do is do this. I think this would actually work. Do like a loopy loop here. I think this would actually work. I'm surprised I didn't think of this before. Does that actually? Oh no, wait. Maybe I don't think that works. Actually, hold on. Okay, I honestly don't know what just happened. I don't see any empty canisters here. Okay, that is a bit bizarre to me. I'm not entirely sure why that happened. What's my next move? I'm just trying to figure out okay, so the idea here is if you yeah, I guess this could technically work. I don't see. So you know, for some reason I don't see any empty canisters here anymore, so I don't know what happened to them. But yeah, so basically you just put these. I'm putting these here just to demo this. But okay, so these are going here. So yeah, I guess I'm really surprised. I didn't think of this before. This technically works. Yep. So this technically works, and I'm really surprised that I didn't think of this before. This is actually not that difficult to implement. Yeah, this is actually not that difficult to implement. I'm actually kind of surprised. So yeah, this is essentially acting as a return feedback loop. So we're taking the excess empty canisters that we're backing up down here, and we're just migrating them up here. And the storage container has a bunch of internal logic that we get for free. So one internal logic is the empty canister gets to decide on what to do with these excess empty canisters. It can either move them into the line down here, or it can just continue. So if I do this, for example, oh wow, that was wait, okay. Uh, yeah, so you'll see that it's taking some of the empty canisters that I just stole, and it's moving them over here. And you can see this was dropping. Um, but yeah, so the storage container is giving us free logic that saves on logistical hookup. Tremendous amount of savings on logistical hookupping, because I don't have to build this complicated programmable splitter or priority merger setup, because this is already doing all of this for me internally. Because the internal storage buffer will decide if the excess will go into these packagers, or if it will continue down the line. And that's exactly what it's doing here. Okay, so yeah, this is much simpler. Yep, exactly. So what Phil said. So it's doing a lot of work here that I'm getting for free. So yeah, the only thing that is required that makes this more complicated than just well, actually, wait, hold on. That's a good question. Oh, that is a good question. Do we actually need this limiter here on the back end of the buffer? That I don't know. That's a good question. No, we still need it, because what's going to happen is that this return line is going to be constantly busy dealing with excess backup here. Okay, yeah, so yeah, you do need that. Okay, so this actually solves all my problems. I'm actually really surprised that I didn't think of this before until now. This is mind-blowingly simple to implement. So theoretically, okay, when we've achieved equilibrium, I think these should stop flowing eventually. But we're not getting like huge amounts of excess coming down this line. We're only getting like trickles amounts, so this tells me that we should be getting closer to equilibrium. Wow. Okay, so I'm kind of surprised by the simplicity of this setup. This is really mind-blowing. Yep, so I'm trying to figure out what should I do today during stream right now. So yeah, something that I haven't done yet that I need to do eventually is I need to create some type of documentation for these blueprints to explain like how everything is supposed to be set up from the user's perspective. So I honestly have never seen this done before with empty canisters, and I don't know if this has ever been documented before. I should look this up, because this might have been documented before by someone else, but it wasn't obvious to me what the solution to this problem was going to be until after a lot of experimentation. So actually, something that we can do right now is we can actually put a limiter right here. Or not a limiter, what is this called? Conveyor throughput monitor, and we can actually monitor the excess that is flowing down the line here. So yeah, it looks like in steady state, you always have this excess of canisters that are not going where they're supposed to be going, and the excess is on the order of around 160 empty canisters per minute. Yeah, Phil, we are currently rerouting the excess back into the beginning of the storage. Um, and yeah, and it looks like the system is achieving some type of equilibrium right now. Yeah, I'm having a hard time continuing to talk during the stream because I'm just blown away by how simple this solution is. So yeah, I think what I should do is let this system run overnight just to verify that there's going to be no issues here for a longer simulation. And again, this is something that the game doesn't teach you in Satisfactory. That I wish it did. It doesn't the game doesn't teach you this type of stuff. Like I literally had to figure this out on my own because I just honestly didn't know how this was supposed to be done. Yep. Yep. So, I gotta figure out what I need to do next. Guess I can do some cleanup here. We'll clean this up right now. So when I when I designed these harmonic load balancers, oh, actually, I should probably show the audience what they look like without this concrete here. So yeah, the reason why, so this is, yeah, let me just take this off. So this is what the load balancer looks like when we take the concrete off. Okay, and let me find another, let me do this one too. So yeah, so this wasn't obvious to me either because I was very concerned that when I was going to build these harmonic load balancers that they were going to be too large to actually fit inside the blueprint. But it turned out that it wasn't that difficult to set these up. Um, Basically, for most of these, not all of them, but for most of them, you have like a power of 2 divider here. So this is each of these splitters is dividing by 2, and then you just take the remaining half and merge it back onto this line here. So this one gives you 1 over 2, 1 over 4, 1 over 8, and then 1 over 16. But we have 2 lines, each one has 1 over 16, so we take one of them and we feed it back into the input here, and now this line is a true 1 out of 15. And that's how you get 1 out of 15, and then you just return the excess down the line. But some of these are a bit non-trivial. Oh, I just deleted them because some, like for example, when you get down to 1 over 12, it's much easier to divide by 3 than it is divided by 2. So you'll see some of the division by 3s instead of divide by 2s. And I I just encased everything into concrete, or the entire load balancer into concrete. The reason why I did that is because there's just not enough room, I think, to fit these load balancers in the blueprints. So what I did was I encased them in concrete so that you can't actually see the clipping between the belts and the top of the reactor. Okay, that's why the concrete is there. And I try to nudge the concrete so that it's slightly offset from the ports here. So it looks like the lines are legitimately feeding into a black box, so you can't see the internals. And again, that's just to hide any of the clipping from view of moving parts anyway. All right. Okay, so I'm gonna delete all of this. Yeah, for those who don't know, this is just a test file or a test save where I have advanced game settings enabled. And I'm just using these advanced game settings to make building easier for me. This isn't meant to be a legitimate playthrough of the game. So yeah, the advanced settings should not be interfering with the actual legitimacy of this nuclear plant running on a legitimate playthrough. Everything here is completely vanilla. There's no mods being used whatsoever, and all blueprints fit within the Mark II blueprint. And the purpose of this nuclear plant is to help enable users to quickly generate power to transition between phase 3 technology to phase 4 technology. Wow, I don't know what just happened. I literally just like walked away, came back, and then we have an explosion of empty canisters. And I'm like, I don't even know where all these came from. This game is like playing mind games with me with these empty canisters. I have no idea where these came from. This is crazy. Oh, it came from this, not running. Okay. That could be because the reactor turned off. Oh, okay, what happened here? We got no power. Don't have any empty canisters coming in. Or sorry, packaged water coming in. Alright, so I need to figure out what happened here. This is really bizarre behavior. Well, it looks like this stream is going to turn into a debugging stream, I guess. Hmm. Wait a minute. What? Okay, this is disturbing. The logic for the internal logic of the industrial storage container is completely different than what I expected. It's basically completely bypassing. So if you look at this right here, all of these empty canisters, they feed in from the bottom here and they leave the bottom. They don't go on the top. That's supposed to be the logic of the industrial storage unit. But here, that is not happening at all. Or wait, where is it? Here. What's happening here is the empty canisters are literally coming in from the bottom. They're completely bypassing this bottom output port and they're going on the top output port here. That should not be happening logically. Oh wait, hold on. Wait, what just happened? It's running again? What? Okay, I am so confused, man. I don't know what is going on. This is like, is this a bug? Like, what is going on here? This is driving me insane. This doesn't make any sense to me whatsoever. Now it's running totally fine, as if nothing happened. Okay, so... Alright, so what I'm gonna do is I'm gonna delete this, and then I'm gonna reconnect it and see if that flips the logic. Yeah, I am so confused, man. I don't know what is going on. This game is playing mind games with me, and I honestly have no idea what is going on anymore. Wait, what is going on? What? All of these lines are dry. What is going on? I don't... What? Did I break something? Okay. What is going on? I guess it's... Oh man. Oh, okay. I guess I guess water is no longer flowing up the stack. Okay, I'm gonna go check the factory again, because it looks like we're no longer producing fuel rods. Okay, I don't see any problems there. Okay, yeah, this should be running totally fine. I don't see... Okay, this game has to be playing mind games with me. This is insane. Yep. Oh wait a minute. Hold on. I just noticed something. The waste is backed up. Okay, that might be the problem. Okay, let me... So yeah, okay, so water may not be making it to the acid blueprint at the top of the stack. Let me go check that. So this is the recycling center, and I don't see any problems here, except looks like we have a backup on the unfizzled uranium. Okay, wait a minute, hold on. Oh no, oh, there's a backup on the pellets. Okay, why are the pellets backed up here? Oh, it's okay, that makes sense. Okay, so yeah, that makes sense. So we're not getting enough electromagnetic control rods in the plutonium. Okay, that makes sense now. Alright, so I need to figure out what is going on with the electromagnetic control rods here. Okay, so we have... So, okay, so yeah, they might be having some problems with AI limiters. No, the air limiters look fine to me. I don't see any problems here. Okay, so my guess is that it was taking too long for the system to receive electromagnetic control rods. I didn't think it would take that long to fill up the buffers. Okay, so the buffers for the electromagnetic control rods for the uranium fuel rod production are already have the buffers filled up, so that should not be a problem there. I guess there was just such a massive delay on filling up these buffers that it caused everything to back up. Okay. Phil, sorry, I said okay. Yeah, so I'm just trying to figure out what my next step is. I think so. This is not adding up to me. So this buffer should be filling up for before we make it down to these storage containers below, but that's not happening right now. It's not clear to me why that's not filling up. Alright, so I'm gonna watch this for a bit here. Okay, yeah, I want to check the numbers here. So we have 3.6 times 3 rods per minute from from that, and then we have plus 4 times 2 times 3, so 34.8 rods per minute, I think. Have minus 8.7 times 4, so that comes out to 0. So that the math checks out. So the number of rods we are consuming should be equal to the rods that we are producing. Alright, so the other thing I'm going to do is we're going to check the sushi line externally, because what might be happening is we might be sinking electromagnetic control rods. Okay, so far I don't see any electromagnetic control rods leaking out on the sushi line. Alright, so I'm looking for the line where the electromagnetic control rods come off the sushi line stack. Okay, it's right here. So yeah, this says any undefined overflow, so this should not be leaking any electromagnetic control rods. So, okay, so let's go back to the, manufacturers again. So we have, so again, these buffers have to fill up before, before the electromagnetic control rods make their way. So, check to see, I think it's this line right here. So yeah, what's supposed to happen is this line has to fill up with electromagnetic control rods before. So yeah, you see how it's building up here? It's kind of hard to see. But yeah, this needs to build up. Actually, we can go on the outside and see this because I specifically built the wall to expose this. Yeah, so these lines have to fill up with electromagnetic control rods before it has a chance to move. Oh yeah, yeah. I guess I should have flipped these lifts around so you can see this better. Alright, so let's look at the ones down here, or no wait, so this, okay, so this is full, this is full, this is not full, this is full, okay, so yeah, that is interesting, and this is set to any overflow. Okay, yeah, so that makes sense. So what's happening is we're only getting half as much rods to the plutonium production than we should be. And it's not clear to me why that's happening here. Oh wait, now it's starting to back up here. Oh, never mind, they're gone. So checking to see if any of these electromagnetic control rods will overflow from this line right here. There we go, so there goes one. Oh, there goes another one. Okay, so we finally have excess control rods leaving that storage bin or storage area. Okay, so I can check on this. So this should be filling up. Okay, so what I'm going to do now is, because we have radiation items backed up on these dedicated lines, and that's not very aesthetically pleasing, what I'm going to do as a demonstration on how to fix this is I'm just going to turn off half of the reactors. So the reason why we turn off half of the reactors instead of all of them is because you need some of the reactors on, because you need some amount of waste entering the particle accelerator to continue the recycling. Okay. Yeah, because you need some reactors on to produce some amount of waste in order to continue the recycling process, because the particle accelerator requires some amount of waste to process the non-fissile uranium. Okay, so that's why we need that there. Okay, so yeah, this is what the industrial storage container logic is how it's supposed to behave. So what's happening here is there's no return empty canisters from the factory, so it's all the excess is going directly into these packagers instead of moving down the line. That's what it's supposed to do logically. So yeah, this is a wonderful test because we're dealing with this recycled backup problem. This is a perfect test to check to see how this new system is going to behave under this new stressing scenario. Alright, so we're gonna go back up here and we're going to check the, okay, that's good. So this is telling me that it is slowly but surely filling up these buffers, so that's good. Okay. Now, I can cheat a little bit here. What I can do is I can put some electromagnetic control rods here. So, what I'm gonna do is I'm gonna feed these two buildings with electromagnetic control rods, but I'm going to leave this one empty to see if it actually achieves equilibrium or not. Because if it's harder. Well, actually, wait. I think I did this before. No, never mind. We don't need to do that. We can do this instead. This is fine. So what I will do here is I'll just fill these up. So yeah, so we have to be conscious about this. I need to go back and verify this doesn't go down. Um, because if it goes down over time, then that means that there's something wrong with the supply. But yeah, so we'll check on those later during the test run here. I just want to speed up. I want to make sure that we're getting rid of waste as quickly as possible here. Oh man, this is so funny. This tower is so tall that falling from the top in free fall, I had enough time to clear out my inventory one at a time. That's so funny. Oh man. Alright, Phil. So here's a question for you. So in advanced game settings, I can enable flight mode, which is a little bit different than hover pack flight mode. So my question to you, Phil, is my question to you, Phil, is what is the flight speed of flight mode in advanced game setting mode in Satisfactory? Phil, you're still looking up the flight speed in the game? Wait, what is the flight speed if we're sprinting? Yeah, so my question to you, Phil, is sprinting while doing flight mode faster than free falling? Well, what is free fall flight speed again in Satisfactory? Okay, so that's twice roughly twice the speed of a train. Okay, yeah, so here the industrial containers are not behaving correctly because there's no empty canisters on this line, so this should theoretically oh wait, this is backed up, that's why. Okay, never mind. So this, I take it back. These industrial storage containers are working properly, I think. No, wait. Oh no, wait a minute. Hold on. No, that's not correct. This is empty, so this shouldn't be going down here. Okay. Yeah, maybe logically what happens is things going from the top can only leave the top. Maybe that's how it works. Yeah, I find that hard to believe. Yeah, that's unfortunate. I may actually have to build special return line setup I didn't want to do. I thought the buffers had all that internal logic built into them, but that doesn't appear to be the case. Yeah, I didn't want to build the return line feedback loop because it's going to look ugly and complicated. Okay, so it looks like that should be working now. So yeah, it is going to take a while, unfortunately, to clear out all of this, all these pellets. Yep. Yeah, just checking on the packagers right now. Yeah, this is weird. So here you can see that on this storage container right here, these packagers coming from the top are going directly into the bottom. They're not continuing down this line. So the logic of these industrial storage containers eludes me. Okay, let's go check on the plutonium fuel rod here. Okay, just making sure that we're actually getting full throughput on those electromagnetic control rods. So I guess if we wanted to speed this up more, what I can do is just turn off all the reactors, because we just need to clear out the pellets right now. Alright, so I'm just turning off all of these reactors here. Okay, all the reactors are turned off. Okay, that's good. Yeah, so I think what I'm gonna do is take a break and stretch my legs while we wait for the system to clear out the pellets here. Okay, so it looks like the pellets in the particle accelerators have cleared out, so now we just gotta wait for wait for these lines to work. Now, for those who might be wondering, do you actually have to do this? No, you don't have to do this. If you just let the system run, it will eventually start working again. The reason why I'm doing all this manual finicking is because it looks aesthetically pleasing if you clear out the lines. That's all. Excuse me. Alright, so I'm going to be right back while I stretch my legs and go use the restroom, and I'll be back to check on the factory. Okay, so it looks like the lines haven't cleared out yet, so we will, what I'm gonna do is, I'm gonna go check the plutonium recycling facility one more time, and then I will go and end the stream. And I just found out that Andrew is streaming today, so I will see if I can do my first raid ever. I've never done a Twitch raid before. So let's try that. Okay, so that's good. I don't see any problems there. And yeah, so we are slowly but surely clearing out all of this waste. Okay. So we will end the stream with a raid. I've never done this before, so let me see if I can figure this out. Actually, Phil, can you teach me how to do that? How do I raid someone on Twitch? Okay, sorry, what was the command again? Okay. Sorry, what is the command again? Okay, that doesn't sound correct to me. Let me try to this. Alright, so it's slash raid, and then the name of the stream. Okay, so let's try that. Okay, and there it is.
I did. I love the Resident Evil games, man. When they got away from like the zombies.
Alert. Fix it approved raid incoming. Paperwork. First raid messenger.
Yeah. Damn, thanks so much for the follow. Thanks for the raid. And welcome in, Raiders. My goodness. How was your stream? And what were you guys playing today? Some Satisfactory by chance? Was it? I'm gonna take a week. Oh yeah, yeah, there was that. Yeah. It's 17th, March 17th, that's right. It is exactly a week away. Next Tuesday, guys. Mark your calendars. Yeah, I am very much planning to just take a day off from work and I'm going to stream all day. So, like, I'm thinking like 12 hours. Yeah. How long it comes to the main version? Oh, so my bet is at least 6 to 8 weeks. 6 to 8 business weeks. Yeah.
Okay.
Okay. Yeah. Thank you, Missy. Thank you. yeah, it's on there. Yeah, I'm thinking at least 6 to 8 weeks. Yeah, there's a lot of stability things that they can do. That gives Coffee Stain lots of time. It seems to be pretty normal compared to like some of the other things that they've, when they go to pull out an update, how long before they hit the main branch? 6 to 8 weeks, the minimum. Now it could be 6 months. It could be. It could be.
What the fuck?
I don't think it will be 6 months.
What the shit is going on out here?
Yeah. That's what I want to know. What's going on out here? Yeah. Panicking some? Yep. Hey, what's up, Freebird? How's it going? Man, that's awesome. This is my first raid ever. Dude. I still remember I was ending the stream and someone in chat said, this was back when I probably had like -6 viewers. Like, hey, you should raid. And I was like, what's a raid? I think I was still streaming on